In section 8, we're going to look at two things. The first thing that we're going to look at is identifying possible rational zeros. So when I say possible rational zeros, we're going to come up with values that could be a zero of the polynomial, but not necessarily. This rational zero theorem will actually help us come up with zeros without using technology. So once we identify possible rational zeros, then we will look at finding all the zeros of the polynomial, just like what we did in section 7. Okay, so starting with the rational zero theorem, what does it say? Well, it says we are going to find the factors of our leading coefficient, which would be 4, and the factors of our constant term, which are 16. So if we find the factors of our leading coefficient, it would be 1, 4, 2, and 2. Next, we're going to look at finding the factors of our constant term. So our factors of our constant term are 1 and 16, 2 and 8, and 4 and 4. What the rational zero theorem says, we need to take all of our constant factors and divide them by our leading coefficient factors. So we're going to take 1 divided by 1, and that will get us positive or negative 1. 1 divided by 2 is a half. And then 1 divided by 4 is plus or minus a fourth. That takes care of the 1. Then we'll move on, we'll go to number 2. 2 divided by 1, that will get us plus or minus 2. 2 divided by 2 is the same thing as 1, so I'm not going to rewrite it. And then 2 divided by 4 is the same thing as a half. Again, I'm not going to rewrite it. I'm done with 2. Go to 4. 4 divided by 1, that will get us 4. Again, 4 divided by 2 is 2. 4 divided by 4 is 1. So I'm done with those. Next, we'll move on to 8. 8 divided by 1 is 8. 8 divided by 2 is 4. Not going to rewrite it. And 8 divided by 4 is 2. We're done with 8. We'll go to the last one, 16. 16 divided by 1 is 16. 16 divided by 2 is 8. I'm not going to rewrite it. And 6 divided by 4 is 4. So from this list, these are what we are going to consider our possible rational zeros. These are our possible zeros that could be located in this polynomial. I'm not sure which ones, but I do know that there are some that are listed in here.